right, class. So today we are going to work on volume of cylinders, cones, and spheres. And we're going to write notes on page 9. Let me slide my booklet over a little bit. So this is Q4, page 9. And today's date is 4/27/2021. The title of the page is Volume of Cylinders, Cones, and Spheres. Those are the formulas, those are the volumes that we focus on in this particular course. Okay, of course you have other three-dimensional figures, but these are the ones that you have to know for this course. Okay, let me slide this out the way for a moment. All right, back down memory lane, we do need to make sure that we understand area, because that's a maintained skill. So that those formulas, they will probably throw on your EOGs, even though we don't teach that in this particular course. They already assume that because you've gone through 6th and 7th grade, that you should already know your area formulas, okay? So I'm going to remind you of what they are, because you may see those on your test at the end of the year. So area is the number of square units on a flat surface. Area is the number of square units and that cover a flat surface. So if you don't remember the definition for area, or what area actually is, zoom in just a little bit. It's the number of square units, and it could be square inches or inches squared, square feet or feet squared, square meters or meters squared, square miles or miles squared. Units is generic. It can be any type of unit that is used to measure length. Okay, length or width. All right. That is the definition of area. We have area formulas that we need to make sure we remember.
It's very important that you write this accurately and in your best handwriting.
Okay, please write this down.
A lot of times, when students are going back to study these at the end of the year, they're like, I can't read my writing. So that's a problem when you try to apply it to math problems.
Okay. Okay, so we have area of a square. The formula for area of a square, let's draw a square. The square, you have 4 right angles, and all of the sides are the same measurement. The formula for area of a square is A is equal to S to the second power, side times side, okay? And since all the sides have the same measurement, you can use the same letter. You don't have to say L times W, because those two letters are different. Since the number are the same all the way around, you can say side times side because it's the same number. So whatever this length is, so is this width. So just use the same letter. Rectangle. A rectangle has still 4 right angles, okay? These two sides have the same measurement, the lengths, and then the widths have the same measurement, but they all don't have the same measurement. These two are the same, and these two are the same. The formula for area of a rectangle is length times width, okay? A parallelogram. A parallelogram is base times height. Remember, this is what a parallelogram looks like. These two sides have the same measure, and these two have the same measure. These are not right angles, okay? The formula for area of a parallelogram is base times height. Base times height. If you cut a parallelogram in half from diagonal to diagonal, it makes a triangle. Okay, so a triangle is half of a parallelogram. All right, a triangle is half of a parallelogram. So the formula for area of a triangle is half of a parallelogram, 1/2 base times height. Area of a circle, remember a circle does not have any edges, okay, it doesn't have any flat parts to it. A circle has a center point. The center is equal distance to the edges of the circle, like a wheel almost. The formula for area of a circle is pi r to the second power, pi r squared. R is radius. That's half the diameter. It goes from the center of the circle to the edge of the circle. Okay. And these are your area formulas. Oh, I forgot one, trapezoid. Sorry, y'all. Your trapezoid has two bases. It's a four-sided figure with two bases. This is the base and this is the base. You can turn it upside down and that could be on its base. There are two bases here. Okay? And they'll always tell you what the height of it is, or not always, unless they want you to find the height. But the height has to be perpendicular to the base. It's not these side lengths. It's from the top, from one base to the next base, it's going to be the height. That measurement will be given. Okay, if they want you to find the area, they have to give you the length of the bases, both bases, and the height. The formula for area of a trapezoid is going to be 1/2 height, B1 plus B2. These are your area formulas. One of the formulas that you need to know as well is the circumference of a circle. Your circumference is the distance around the circle. Like almost like the perimeter of a circle. There are two formulas for circumference. You have C is equal to pi d, or you have C is equal to 2 pi r. And I'll pause for the calls to give you a chance to write, okay? Any questions for this part? The easiest way to remember formulas, what I found, is either to continuously write them, that's old school, and or to put them in flashcards and have somebody call it out to you, okay? Or matching, you can match them up. So many different ways that find a way that is easiest for you to study. If you're a visual person, then try to write things out so you can see it, or use flashcards. Okay, if you learn by hearing, have somebody call it out to you and you all call it out. If you're kinesthetic, do the matching game. Put it on note cards and face them over and start matching them. Put words on one, the formulas on the other cards, and then match them together. Okay? So those are different ways that you can study. Try them and see what works best for you. Okay, so now let's write the formulas for volume. Got our volume formulas now. There's three. We'll do three columns. We got volume, we got cylinder, cone, and sphere. Cylinders, cones, and spheres. Okay. The formula for, well, let's draw a cylinder first. Not an artist, but a cylinder is kind of like a can. It's the shape of like a can or a closed cup or jar. Those are cylinder-like figures. The formula for volume of cylinders, and remember, well, if you don't know, let's go ahead and write the definition for volume. Your volume is going to be the number of cubic units within a three-dimensional figure. So that's what I should have wrote first. Volume, the number of cubic units in a 3D. Okay, in a 3D shape, solid, however you want to say that. So it's how much space is within a 3D air is within a solid. It's that space. It's that 3D. It's how much space is inside of a cylinder, or how much space is inside of a cone, or how much space is inside of a sphere. And you're always going to say it's cubic units because it's the third dimension. It's not flat anymore like area is flat. Okay. So now we have the formula for cylinder is going to be pi r squared times the height. Okay. So when you get ready to fill up a cup, okay, the first thing that you fill up is going to be the bottom part of the cup or the bottom part of the cylinder. The bottom part of the cylinder, of course, that space is the area. That's a circle. So it's area of a circle. And then as you continue to pour water in it to fill it up, what increases? The height increases. Okay. So the formula is the area of a circle. Formula for volume is the area of the circle because as you pour water or pour some type of content into a cylinder, the bottom part has to fill up first. And then as you keep pouring water or liquid or whatever into that cylinder, the height is going to keep increasing. So the formula for finding the volume or the space within a cylinder is the area of a circle, pi r squared, times the height. Okay. A cone. See what that looks like. I'm going to draw a cone this way. This is what a cone looks like. The space within a cone is actually a third of what you can put in the cylinder. So what that means is it takes three of if it's the same height, if this cone is the same height as this cylinder and the base is the same area as this cylinder, it's going to take three of these cones to fill up this cylinder. Okay. So the cylinder is 3 times as big as a cone. That means that a cone is a third of a cylinder because it takes 3 cones to fill up this cylinder. Since we know that information, the formula for finding volume of a cylinder or the space within a cylinder is 1/3 the formula of a cylinder. It takes 3 cones to fill up this cylinder, provided, of course, that they're the same height and that these bases have the same area. Okay? Any questions so far about the relationship between a cylinder and a cone? Cylinder is 3 times the size of a cone, so that means that the cone is a third of the cylinder. It takes 3 cones to fill up that cylinder. Again, provided that they are the same height and that the base is the same area. Okay, this circle on the bottom is the same size as this circle on the bottom. A sphere. I ain't gonna lie, I can't really draw a sphere. I'm gonna do the best I can and just do a circle. I don't know, because they might do. All right, so your sphere is like a globe, and I'm gonna put example. So when you go back and look at it, you won't think it's just a circle. Okay. And the formula for finding the space within that sphere or that ball is 4/3 pi r to the third power. 4/3 pi r to the third power. Okay. Any questions about that? And I don't. There's no real easy way to remember the volume of a sphere, but I will tell you this: all of these are circular. So notice how every single one of these formulas have pi in it. Okay, and remember the number that we use for pi is 3 14/14, or we use the fraction 22/7. It's not the actual number, it's just about. So that means I should put squiggly, right? Because it's not the exact number. They've rounded it to either 3.14 or 22/7. And let me put this in a bubble so it doesn't get lost in all of what I've written. This is your notes for volume of cylinders. Please make sure you study. The formulas are not going to be given to you, so please put them on flashcards and study them, okay? You have time. You can remember these. It's basically 3 formulas that you really have to know, unless you forgot your area formulas. And if you've forgotten those, you need to go back and write flashcards for those as well. Okay, so now we're going to move to guided practice problems. Remember, I showed you where those guided practice problems were on the Canvas page. When you go ahead and open those up, raise your hand if you are still copying this. Okay, good deal. So now we're going to move to the guided practice problems. If you are still writing, please don't be ashamed in that. Just let me know so that I can slow it down for you. Okay? On this, I need you to show your work. Okay? I need you to show your work. It's super important that you show your work on these problems. You will need your graphic calculator. Let me get the one that you're going to be using. You will need your graphic calculator. I'll give you time to pull that up. I'm going to pause the video. All right, so here we go. Zoom in just a little bit. All right, so for this problem, it says we're going to find volume of cylinders, cones, and spheres. And we just drew pictures as to what they look like. We're going to find the volume by using the volume formula. And we're going to round our answer to the nearest tenth. So that means we have to use the calculator to figure that out. All right. Okay, so this shape is a cone. So that's what we're going to write here is cone. We're going to write the formula for volume of a cone. Remember I told you that a cone is a third of a cylinder. So the formula is 1/3 pi r to the second power. Okay, so now we are going to substitute the information that we have. We have 1/3. Pi is 3 1400ths. The radius, look, this right here is the diameter. Oh, I forgot the height. Sorry, y'all. Times the height. 3 1400ths. My radius is half of this diameter. My diameter here is 4. That's all the way through the center of the circle. Half of 4 gives me my radius. So my radius is going to be 2. So I have 2 times 2 to the second power. And my height, this is laying sideways. It's not standing straight up, but it's still the height of this cone, okay, because it goes from the base to the very top. So this is going to be 12. Okay. So now I'm going to type this in my calculator so that I can get my answer and round it to the nearest tenth. That's one space behind the decimal. So let's type this in together. I'm going to clear my calculator, second plus 712. And I'm going to type this in. I have 1/3. So parentheses 1 divided by 3. That's how I do 1/3 in the calculator. Then I have times 3 1400ths. Then I have times 2 squared. So this is 2. My square button is right here. This is where my square button is. Okay. And then I have times 12, which is the height. So when I type that in, this is what I get as my answer, and I want to round it to the nearest tenth place, one space behind the decimal. So that's about 50.2. So volume is going to be 50.2. Squiggly lines because it says it's about. This is feet to the third power. Remember, by definition, volume is the number of cubic units inside this cone. So that's going to be to the third powers, the third dimension. Okay. All right, so now let's look at the sphere. Please let me know if I'm moving too fast. This is a sphere. The formula for volume of a sphere is going to be V is equal to 4/3 pi r to the third power. We're going to substitute the information that we know. Okay, we got V is equal to, bring down the 4/3, so part of the formula, times 3 1400ths, which is pi. The diameter is 12. From here to here, the diameter goes through the center of the circle, and it's 12 centimeters. The radius is half of that. So the radius would be what? Anybody? What would the radius be? 6. Very good. So we have 6 to the third power. So now we're going to type this in and round it to the nearest tenth place. Watch how Miss Reyes types this information in. Slide this over a little bit. So now I'm type this fraction in, 4/3. So that's parentheses, and parentheses is right above this number right here, 8. So we have parentheses, 4 divided by 3, close the parentheses. Okay, that's 4/3. Then we have times 3.14. Then we have times 6. And then we're going to raise it to the third power. So we're going to press the caret key right here. That gives us this in our calculator to the third power. And that's how we type this in. Okay. Now we're going to press enter. And we're going to round to the nearest tenth place. That's one space behind the decimal. So this is 904.3 or 3/10. So this is about 904 and 3/10. And this is going to be centimeters to the third power. Remember, volume is the number of cubic units within a 3D shape or solid, or however you want to say it, within an object. Okay. Let's look at the next one. This is another sphere. Okay. The formula for volume of a sphere is V is equal to 4 over 3. Notice how I rewrite the formula. Even though I know these formulas by heart, anytime I'm working out problems, I always write the formula because it minimizes the mistakes that are made. Okay, so we have pi.
It's just a visual reminder of what to plug in where.
Absolutely agree.
And I noticed that a lot yesterday when y'all were working out the Pythagorean theorem. If you didn't write a squared plus b squared equals c squared, you plugged in the wrong values for the wrong letter. So it's super important that you write that formula.
It is very, and even I've done it a million times, literally, and I still write down my formulas. Okay, yeah, because it's easy to make a mistake, and you've seen me make mistakes before. So, I mean, it's so easy to make mistakes. So just go ahead and write it out. We got V is equal to 4 over 3 times 3.14. And our radius here is 5.9. R is equal to 5.9 in this problem. So we're going to put 5.9 and we're going to raise it to the third power. Okay. This time they gave us the radius instead of giving us the diameter. So now let's type this in our calculator and round to the nearest 10. Okay. So slide this over a little bit. So we're going to type in the fraction 4 over 3. So parentheses 4 divided by 3. Close the parentheses. This is how you type in that fraction. Then we got times 3 and 1400ths. Then we got times. We got 5.9. And we're raising it through the third power. So look, I'm going to press the caret key right here. And this is what I get. And I'm going to raise it to the third power. Okay? So that's how I type that in. Now I'm going to press enter. Please make sure that you do this with me, because if you don't, then you're not going to know how to do it on your own. Okay? So it's super important that you take your calculator out and do this with me. Okay? Press enter here. And look at what this gives me. This gives me 859 point, and I rounded to the nearest tenth, so this one space behind the decimal. Now, since the number beside the 8 is 5 or higher, then this 8 is going to go up to 9. So my answer here is going to be about, because I'm rounding, 859 and 9/10. And this is what? Kilometers to the third power. Volume, by definition, is the number of cubic units within a space, okay, or solid, or object. Okay, so now I'm going to go down. I'm going to skip these, and I'm going to go down and do number 7, because number 7 is a cylinder. We've already done a cone, and we did 2 spheres. So now let's find the volume of a cylinder. So here we're going to do cylinder. Again, volume is the number of cubic units within a cylinder. So the formula for volume of a cylinder is the area of a circle. That's pi r squared times how tall it is, the height. Okay. So we're going to substitute the information that we have, or that we know. Pi is 3 and 1400ths times my radius here is 5. So I got times 5 to the second power. Then we got times my height in this picture is 11. The height of the cylinder is 11 miles. Okay. And this is multiplication. I don't want you to think that's a decimal or something. So now we're going to type this in the calculator to see what we're going to get as our answer. And we're going to round to the nearest tenths place. So let's type this in. We have 3 and 1400ths, 3.14 times, we have 5 squared. The square button is right here where you can use the caret key and press 2. I'm going to square it. And then we have times 11. That's how we type this in. Slide this over a little bit. And press enter. So this gives me 863.5. 800. Oops, sorry, y'all. 863 and 5/10. And this is going to be miles to the third power. Because remember, volume is the number of cubic units within a space. All right, any questions about this? Okay, I want you to do the following on your own. I want you to try number 5, number 6, and number 8. Okay, 5, 6, and 8. These are the ones I want you to try on your own, and I will go over them on Thursday. But I need you to try those on your own. 5, 6, and 8. Let's go ahead and do those now. Let's go ahead and do those now. Questions, comments, or concerns? Okay, I'm going to go ahead and stop my video. Remember, if you need to go back and watch, please go back and watch, okay?